about we have talked about classes, we have talked about arrays, we talked about inheritance both of interfaces and of classes. Um, Now we are going to talk about collections, which are a generalization of arrays. What is an array?
Object.
It's an object, but what does it have?
Values.
How many?
How many?
It has a bunch of things, right? And all of those things are of the same type, right? And we talk about them, we refer to them by number, right? Rather than by name, right? It's not in an object you have variables, instant variables, but they may be different types and they have names. For an array, we just use numbers, right? Now, one obvious generalization of the idea of array is a list. But we are going to have to talk about weird syntax. In an array, right, you don't have just arrays. You have arrays of ints, or arrays of strings, or arrays of this, right? We haven't seen how to do that on our own. Java does allow you to define generic functions and classes and stuff. We use the angle brackets to put the class. So we will have a generalization of arrays, which is the list. So it can declare something to be a list of integer. Actually, I don't like this. I'm gonna go do it in here. Um, Most of the collections go in the java.util package, and you have to import them. What's a list? This one may be right. Never mind. And actually having interfaces helps. The actual hierarchy is more complicated, right? We have abstract collection, then abstract list, and then array list. The interface list to me is kind of the generalization of an array. What can I do with an array? store values, I can do, right, get a value at an index or set a value at an index, right? That's the main thing, right? So Java doesn't support operator overloading. So let me do this. I could do what a list gives me extra on top of an array is the ability to grow. So I can do l.add 3. 4 and 5. That I cannot do with an array. With an array I cannot do add. Now I can do, instead of length I have size. And this would give me 3, right? Has nothing to do with me. We didn't run something on the last time. Okay, now it's working. Now, it would be really cool if I could do something like for int I equals 0, I less than L dot size Java doesn't support operator overloading, so it doesn't let me use the fancy square brackets thinking, right? So they came up with, well, that's just calling a method. Just call a friggin' method. So this is get. Other than that, it works.
For an array, you wouldn't have to use get.
For an array, I wouldn't have to. In fact, I don't think I can, but maybe. I use square brackets. In here, I need to use get. Also, my type, right, here is with angle brackets.
So a list can do some stuff that an array cannot do.
It can grow.
What can an array do that a list cannot do?
The only thing that it can do is contain primitives. Lists cannot contain primitives. Collections in Java cannot contain primitives. So we need to use the fancy stuff. My list is not a list of int, it's a list of integer. But other than that, arrays tend to be used to implement a bunch of the other collections, but you don't know. Yes. We can also set things. So if I want to do here something like L of I equals L of I plus 1, right? I can't do it with square brackets, right? We have seen that I can replace this one. What can I use instead of this L of I? L dot get I, right? Now, on this side it is different, right? I need to set the value. So what Java will force me to write is isn't this ugly?
It's not that bad.
Just ugly syntax.
So the set is like, it's a method that says what it was, what it becomes.
Not what it was. Is um, where
Where it was.
where what do you stick in that box,
Okay.
right? So on box number I, you stick that value.
Okay, so get returns a primitive.
Get returns a value. Not it cannot be a primitive, it's an object, but yes, returns an integer, right? So when I is 0, L dot get of I would return what? What did I put? What did I stick on the 0th element?
3
So L dot get of 0 would return 3.
plus 1.
Plus 1 is 4, so what I stick in there is 4. So if I run this, instead of getting 3, 4, 5, I'm going to get what? 4, 5, 6. Maybe. Or a compiler error.
But you don't have 6.
What do you mean I don't have 6? Occasionally. No. Does that make sense?
But it looks weird.
It is almost the same as an array, right? But I can grow.
Yes, what you can do with it is just a little bit more.
Because I can grow it. My array is of a fixed size. Here, I can grow it.
There's nothing that you can't do with a list that you could do with an array. You just need to change any primitive variable.
Arrays are more primitive than lists. So lists are built on top of arrays for the most part. Now, list is an interface. My implementation is array list, is the one that I commonly use, but I could have other kinds of lists. In fact, we're going to talk about them later.
Oh yeah, so that's just an array list. There's all this different concepts.
There is different kinds of lists. So list is an interface that gives me, it actually has more stuff. Give me add. I can add at a specific index. I can add another collection, clear, remove everything. I can ask it contains. Do you contain this object? Equals, that's from every object. I have get. I can ask index of. You probably.
From our perspective, the fact that an array list is an interface.
List is an interface. Array list is a class.
Okay, so only a list is an interface. What do I have to keep anything in mind that because it's not a class, it's an interface? I have to do something
No, it's more use the interface. Use as generic a thing as you can, because that will make your code more generic. So when you define a function, let me do. Let's do this. How can I add up all the numbers? Yeah. And an accumulator, right?
Yeah.
Well, I'm not using, I'm doing sum plus equals numbers dot get, right?
So the dot size is kind of equivalent to like
Dot length. But of course, right? To keep you on your toes, they couldn't call it length,
Okay,
right?
I was about to ask, like,
I mean, because the poor kid that designed these things had ADD, so they would switch from one to the other. There's, sorry,
You're doing like an attempt to unify it, so it's like kind of the same thing.
they do.
it's called
It's
Python,
no. Like Java tries, is more they have to keep all the old stuff around because now there's tons of code that uses the old one. So maybe they unified on size. So I think what they did is they built a class that takes an array and makes it behave like a list. So it just directly calls, right? Directly replaces all those things. And that one has a size. But they didn't add size to the array object. So they try sometimes. It's a problem when you have legacy code. Then the newer languages can just say, "Oh, forget about it. Just call it the same," right? It's been bugging me for 10 years, so I'll make it all size. But so what does this let me do? Static. So it added 4 plus 5 plus 6, right? Because I still added 1 to all of them. Right? Now, what I'm passing to this is an array list, right? Why can I not just do this? I can, it works, but now my function is slightly less useful. It will only work on array list as opposed to on other kinds of lists. Does that make sense? So ideally, I would call list. Right?
what kinds of lists is it?
I think linked list is actually the other one. But there may be like the one that goes from an array is not an array list. It's a different thing. But I just changed my implementation to linked list, and voila, it works. No problem whatsoever.
So we have like the L dot add. Is that adding 3 to the link, or is that adding just 3 to the list?
To the list. It's adding an element to the list.
Okay.
In fact, maybe actually well, now this doesn't work. Ha ha ha. What's this going to print now? Yep. Maybe. Yeah. Does this make sense?
I'm sure that you can just add like a string as an object. You don't have to like declare a new object and then say add to it.
It's just for strings, but yeah. Well,
but for integer it works too.
It has autoboxing and unboxing. Yes, I don't need to do new integer of 3. It just knows that it's 3.
Yeah.
So, yeah.
It's convenient. I mean, it'd be obnoxious
Yes.
if it didn't. But.
It didn't at the beginning, and it was obnoxious.
Oh, so you
Java
need to, like,
7,
create a
I think,
new,
added it.
Integer every time
Yeah.
you make that.
Yeah.
three
Java 7, I think, added that stuff. Maybe.
I see.
But this is not terrible, right? It is basically the same as a array. The same-ish as an array, right? Actually, I could also do, this is a lot more useful on these things. Rather than this, what did I do with an array? What's the other loop that I have? The for each loop, right?
Yeah.
I can do the same thing.
I was wondering why you didn't use what's your favorite loop?
Yes. So this also works. And this is actually what we tend to use most of the time, because we have, or at least in my domain, we normally have lists or collections of stuff, and we just go over them. Does this make sense? So this is a generalization of array with the ability to grow. I can do add. And then it actually has a couple of other things, right, that are nicer. I could add at the end, those kinds of things. Does that make sense? It's an interface. List is an interface, and I have several implementations. The two most common ones are linked list and array list. We are going to talk a little bit more about what they do. You understand how lists work. You understand the mechanics.
Yeah, it's an array that you could do more cool stuff with.
You can add elements to it. Now, there is another generalization of arrays, right? In an array, what's the index? What kinds of things are in the index? The index has to be an int, right? Doesn't that suck? Wouldn't it be cool if I could have something like an array, but where the indexes could be strings or donuts, right? That is the idea of a map. Let me change this to...
So a map in Java is not like a math map?
It is sorta, kinda. What's a mapping in math? In math?
It's just this one goes to that one and this one goes to that one.
Yes. So, right, if you think about it, an array is a mapping. It maps integers to values. It maps 0, 1, 2, 3, and 4 to Joe, Jane.
Right. But an array has a static length, and
it's a slightly less general idea of a mapping, but it's a mapping. It maps numbers to values.
Right. It's like that.
A map is like that. It maps values of one kind to values of the other kind. It's almost like a small database.
Do you use this? I don't know what to call it. Is it a data type of the map?
Yes.
Do you use that for graphs? Or
you could.
Or what would you normally use for
everything?
Okay, all sorts of things. Okay. Okay.
And again, map is our interface. This obvious implementation is the hash map, which uses a hash table.
Yeah, we've gone over that.
It's a hash table. It's a magical word. We're going to talk a little bit about them later. That's the data structures class.
You can't use your cursive language. You can't define it.
Yes,
yourself.
recursion. See recursion. Just know that they're good. Of course, right? You would think that given that this is a generalization of an array, you'd put stuff there with set, right? Of course, you know how the story ends, right? You don't. You use put.
Oh. So if the list can do everything an array can, but then you get the headache of not being able to add elements, why do we use arrays and not just list everything?
Because arrays are faster. Basically, on the other hand, you normally don't use arrays. We use them just in a week in class because that's the most basic concept. But after that, you don't use it except when you're building a list. After that, you just never use arrays. You use array list or vector. Oops. So we're going to translate, right? English to Spanish.
Oh, I know this from Sesame Street.
Yeah, I can do them in Chinese. 1, 2, and 3. That's it. There was a really annoying commercial with that singing all over. So now this allows me to do at least they were reasonably consistent. Size is good. And then I can do so the first thing would print what? Well, line 42 would print 3, the number 3, the digit 3, and then line 43 would print uno. Isn't that cool? A map allows me to it's almost like a database, right? Isn't this uber cool? And of course, it could be from string to person or from string to product, right? And I can have, I can combine this until I get really tired, right? So I could have a map of list of string to map of string to list of string. You shouldn't, but you can. Does that make sense?
So the 1, 2, 3 are the keys, and the uno, dos, tres are the values.
Yes.
Contains key just returns if the map has a.
Contains key returns true if the map contains that thing. So
It has a value for the given key. So it's just if it has a value.
yep, contains key. this would print true. What would this print? False, right? I'm
What
actually
if you,
running that thing. I did not.
What if you map the same key to different stuff?
You can notice you would override
Override it.
unless you map a key to a list of things, which is perfectly okay.
What was the list of things? What, even two lists of things that are the same?
You would like you could map say would be okay.
I'm thinking of ways to break it.
Yeah, you can't break it. If you do this, right? If I do this, and I put the French string instead of the Spanish one, right? What happens is that when I print this, right? I did this. I tried to put two mappings for the same key. 3, right? It doesn't work. What happens is that the second one overrides the first one. The first one is not there anymore. It would print 3.
But you say a map is like an array, or it's like a list?
It's like an array, but the keys don't have to be integers.
But there is an order of them.
Well, yeah, no.
So it's not like an array.
It is like an array. What is an array, right? An array is something that maps values from one kind, integers, to values of another kind. Right?
I guess I think of it as an order, though, because it's 0, 1, 2, 3.
Yeah. So it is like an array in some ways, but not like an array in others, right? If it was exactly like an array, then it would be an array, right?
But it's not. So it's technically it is not ordered. So there's no way we could like look at the first one or the last one. Or the one.
If you think about it, arrays are not ordered. It's integers that are ordered, right?
Okay.
And so on.
If you like have the keys be things that can be ordered, like in alphabetical order or something.
Yes, then yes.
You could figure it out, or your code or whatever.
Yeah, the keys are ordered. Now, I can also ask the map to tell me which keys does it have. But that thing is a list, a collection.
Can you make a key without a value?
No. Yeah. Okay. Actually, we need to do slightly more complicated stuff. A collection is slightly more general than list. A list implements a collection. And a collection only has the iterator. Oh, a collection only allows you to iterate but doesn't have get and set. So you can only go through all the elements in a collection. Now, within linear collections like lists, there are some other restrictions. One of them is a set. A set is not ordered. I mean, you still have 0, 1, and 2. It's just, and also eliminates duplicates.
Yeah.
Right? So a set is a collection that doesn't really have order, so it doesn't make sense to have get and set.
You mean
And
for the values that has not the keys?
well,
Or it doesn't have keys and values. It just has.
it doesn't have keys and values. It only has
Okay.
values, right? And
No,
so the set of keys of a map is an actual set, not a. So you would have a collection.
Right, because they'll override each other, so that they'll never have duplicates of the keys.
They'll never have duplicates of the keys.
So you could think of it as a set.
I can also
Can you do copy that line real quick?
control Apple C, Apple V.
Mine didn't. You meant like highlighting, so I was curious how you grabbing the whole
I
line.
did. I did this stuff, right? Maybe. I don't know. My fingers do stuff.
It's like a coding whiz, you're going so fast, you know.
Yeah, nah, it's just most of that stuff you have it memorized. Actually, my fingers are dumb now because I switched so much from Linux to Mac that my fingers don't know the keys because they're different in every other thing. I became really, really good. I was using a Mac and running VMs of Windows and Linux inside, and I became really, really good at not even thinking about switching from one to the other. So I would do Apple C on the Mac, switch to a Windows thing, and do Control V to paste, and then switch to a Linux thing and do Shift Insert and all of that stuff. But nah, not anymore. Now I use more than one machine. My fingers don't know where this stuff is. I can get all the keys. I can get all the values. And of course, it's not value set. It's just values because you don't want it to be too. You don't want it to be too much the same. You have to add variety, right? Well, it's not keys. It's key set, and it's not value set. It's values. It's like why? Pick one, right? Either do keys and values or do key set and value set. But
So dot key set returns a set.
A set of keys.
And dot a set of keys, and the dot values returns
a set of values.
So it just doesn't say values.
Yes. And we actually have a way to iterate over all the entries in a map.
What's that entry?
Map.entry has key and value, so that will give me, right, that would allow me to see it as kind of a collections of keys and values as opposed to a mapping.
And technically that's returning a, what kind of value is right? Dot entry set.
It's a collection. It's a set, actually.
Is it a set?
A set is a sub-interface of collection.
I was just thinking it can't be a set because it returns the key and the value, and the order is important.
No, it's not important. Why would it be important?
You gotta know which one's the key and which one's the value.
But the order of the entries is not important.
No, that's not important.
Right? So the order of the thing that you're getting returned is not important.
Okay, so it's giving you a set of
entries, a set of map.entry. Map.entry is a class that has key and value.
Okay. And wait, so is entry a data type?
Yes.
Oh, it is. I didn't know that. So it's just an entry is just like a one.
It's one entry in a map.
Yeah, one thing in map. I'm being really particular about this because it's tough for me to keep all this in my mind. So, yeah, that's a set.
Yeah. So we could do something like this. That would print a bunch of things. That's that for loop.
This time it didn't override.
Yeah, we overrode, right? So for tree, we have 2R rather than 3.
So the second one is a value.
Yes.
Translation is.
Yep.
So entry has this get key method, but map has get, and then in parentheses you put the key.
Yes.
I'm just looking at this thing. So it's not the same.
No.
It's like this. It does the same thing. It's just the syntax.
Well, except that
slightly different.
an entry is one of them. A map is a bunch of them, right? So
Is a map like technically based on just a bunch of entries, or are they separated?
it is a bunch of entries, but you're not allowed to know how the heck it's done inside.
I
Right.
think about that yet.
Yes, think about it on the data structures class. Actually, we'll talk about data structures a little bit, and because we'll finish relatively early, and then we'll go talk about data structures just to.
Okay. This is enough for now.
Yes. Isn't this cool? This is incredibly amazingly cool, right? Let me go through the notes to make sure. We talked about generics. We talked about lists and some of the things that you can do. Add, get, set. Size, you can ask is empty. You can ask it to remove. And you can go through like this. And maps, you can map from objects of one type to another. And they can be, right, different types or whatever. They can be complex types, right? So you could map a string to product or something like that, right? And then
You're saying you could like map the word to the number 3.
you could, yes. Yeah. And we have get, put, contains key, remove with a key, size, and then key set, entry set, and values, right? Java also has set, queue, stack, dequeue, and others, right? Their collections, they don't have they have add, but they don't have add at an index, right? So they don't have set. They have add only. A stack, a stack has the property that whatever you put in first, right? And I linked to the wrong thing. Isn't that cool?
put stuff on top of each other, and then you can only take off from the top.
Yes, you can only
Right, to the
take
top.
from the top, so it is left in, first out, or first in, last out, right? Whereas a queue is FIFO, first in, first out. A stack is LIFO, last in, first out, right?
Next to your stack can overflow since there's a lot of terminology I want about that.
Your Java stacks cannot overflow, but it is similar to the stack of your function stack, right? The way that programs work and computers work, right? If you create new objects in memory, what do? Well, I need to allocate this memory, and I need to somehow keep track of you are using this memory, so I cannot give it to anybody else, right? So allocating and deallocating memory is a pain. Whenever you do new, the operating system needs to say, oh, I'm going to give you a chunk of memory, and I'm going to keep markers that you're using it, and eventually you don't know it, but Java has garbage collection. That memory will be returned to the OS, right? But the OS has a lot of overhead on keeping track of who is using which memory, right? You need to use memory to keep track of who is using that memory and all of that stuff. With functions, we don't really need that. We can just, when you call a function, I will store where am I in the program in run, and then I will store local variables, right? And if you call another function, I will do the same. I will store the parameters, and then I will store space for local variables. And then if you call another function, in fact, I can do the same, and I can do the same, and I'm growing. When you return from the function, my deallocation is super simple. I allocated 10 bytes for these two variables, so I just deallocate them. I just subtract 10, and that's where I am, right? So allocating and deallocating memory on a stack is super fast. I just add 10 or subtract 10, right? And so programs use, or computers tend to use stacks to do function calls. So that's the stack that overflows. These stacks won't overflow. They may return an out-of-memory exception, right? If you try to add too many of these things, eventually you run out of memory. With a really long eventually, but sometimes you do, right? So we have stacks and queues, and set is actually useful, right? Because many times you want to check for duplicates. By the way, if you remember, we talked about classes. Our classes have an equals method that's used here, right, for checking for equality. We also, although we didn't really talk about it, there is a hash code method that's used for when you use hash table thingies that you could override or just let Java use, whichever one it prefers. For when you define your own classes. Now,
And why would you want to use that one instead?
the one that Java defines, because you're lazy.
No, I mean, I understand why you'd want to use dot equals, but why would you?
Oh, it's when you create a hash table, when you create a hash map, it's going to be using the hash code method that you defined. Right?
Wait, did you just tell us what hash tables were?
No, I lied. Okay, let me super quickly explain to you what hash tables are. Sorta, kinda. No, I won't not. I will explain it later when we start doing more interesting stuff. Now let's do examples of collections. I'll later on explain what a hash table is, because you need you need to do stuff. What is good to do with collections? Let's do a couple of interesting things. Well, we did maps. Let's do, let's play with a stack, because this is mildly interesting.
We should take a stack, sort it, and then put it back into a.
Well, you could do, but yeah. There is a, actually, let's do, first of all, something super simple and dumb. They are all collections. They all implement the interface collection.
So there is at least some methods that you keep using it over and over. It's not as like everything.
You tend to use all, right? In fact, we're going to use add, right? How can we use a stack of character to reverse a string? What we are going to do, right, is for car C S. Can I do this? No, that is horrible.
Put them all in order, then you take them all out in order, and then it's automatically reversed.
For int I equals 0, I less than s dot length with parentheses, because it's not.
So an array uses dot length with no parentheses.
Yeah.
Everything else uses with parentheses.
Except that some use size and the others use length. Because if not, it would be actually convenient. I mean, variety is the spice of life.
I think for an array, at some point you need to say what the length of the array is before you can do anything with it.
What do you mean?
Do you need to specify the length of the array before you use it?
When I create an array, I have to specify its length. When I do new, I need to specify the length.
You don't gotta specify
No.
including the list.
Well, you never. A list is an interface, so an array list or something like that, you would not specify the length. Oh, that did not reverse it. That did not reverse it.
You gotta start from that has the array and going down.
No. What we're trying to do is cheat. Yeah, we can do it easy, but we wanted to do it complicated. When I iterate, I'm actually, I can do pick and pop. So what I can do is,
Push and pop.
it's the equivalent of push and pop, right? But I can do add or push. Let's do push then. let me, oh, that may be why. Let's see if I just do push. Maybe we need to do pop, but we'll see. Now reversed? No. So what I need to do here is empty. So I can't iterate over all the elements because it's not specified in which order they are. While node letters dot is empty, and equal ends plus letters dot pop.
And pushing and popping is the only way you can put stuff into it and take stuff out of it.
Yes-ish. Yeah, that is the more stacky way of doing it. A stack is a collection, so you can do add and you can do other things, which is what I did and didn't work. Yeah.
What was the other one that we didn't do? There was pushing, popping, and
Peek.
what's pick?
Peek lets you look at the element at the top without taking it out.
Is that the same as top?
Top, yeah. But Java calls it peek. Yeah, other when you see a stack, other people will call it top. Pop actually takes it off the stack. So this is to look at it without.
So pop's doing two things. It's removing the top thing, and it's also returning that thing.
It returns that thing, yes.
But sometimes you don't need to return. You just want to get rid of it.
Then just don't use it.
Okay.
Right? The fact that it's giving it to you doesn't mean that you have to take it. Just drop it on the floor. Actually, yes.
Oh, I got a question on the class. How you call from the one class to another private? Can you
What? No.
figure any private
If it's private, only you can use it.
in that class?
Only this class can use it.
But there is no way you can call.
Other class can have an instance and call my public methods.
Yeah, how you do that?
What do you mean? How do you do that? The method is public, right? If I'm here, I can have com dot okaram dot inheritance dot circle c equals new just create a circle and right in here I could do well if I had a method here that wasn't static, right? Or if this was static, then in here I can do.
So public really means public, like somebody from another galaxy.
Yes, public means anybody.
It's not just the packet.
No, if you leave it, if you don't mention public, private, or protected, then it's anybody in the package and sub-packages. If you leave, or actually super packages. If you say public, then it's anybody. And normally you have some public methods and some private ones. So this would be how we reverse a string with pushes and pops, with stacks, which is horrible. But, the one that I wanted to show is Actually, we can do this. What we are going to do is we are going to put a bunch of strings in my stack. And, oh, that is horrible, but let me do that. I'm going to combine either numeric strings or operators, right? I could actually have set of string
So this, like take a big string that's like 0 plus 3 minus 4.
yes, but we are gonna cheat and use, I hate you sometimes, IDE, just don't do it, don't do it, yes, beautiful. Why did you add all that stuff? Oh, I need to do, what kind of set? Let's do hash set. Woohoo! We could have our expression can be in different ways. We tend to use infix notation, right? Where the operator goes in between the operands, right? You can also do prefix notation, which is what we do with functions, right? Where the name of the function goes before the operands. So we could do plus 3, comma, minus 4, comma 2. This is not valid Java, but, right? That is kind of what we do with functions, right? That's called prefix notation. There is also postfix notation, which is put the operands first and then the operator. So in this case would be 2, 4, minus 3, plus. Why would you do that? There is a really cool thing about this too. Prefix notation always requires parentheses, which is horrible. On the other hand, it makes parsing really simple, right? It's like, yes, you always have parentheses. Your expressions always look the same. As opposed to in here, sometimes you have parentheses, sometimes you don't. With this one, you never require parentheses. Because, right, when you see the operator, you can just look and you'll have operands here. We're going to actually implement that algorithm. So you never require parentheses, which is cool. So you do add, subtract. Let's do multiply, right? So imagine that you have this. Here, you don't, in here, actually, imagine that you do this, right? To do it with, in here you just do 3, 4 plus 2 times.
So false order operations and everything.
How do you write the negative numbers in the
It's not. It's a different kind of operator, right? So postfix requires that you don't have the same, that you don't use the symbol for more than one thing.
Well, you gotta get your spacing right too. Also.
Yeah. So what we're gonna do is not. You could use commas to separate or something like that, right? So what we are gonna do is operate like this. And we are only going to have binary operators, right? We could have more complicated stuff. But, so how do we, let's do this. We're going to have an operate function. I'm going to transform those into ints, and then I'm going to have a horrible if statement.
So the parse int, it takes an integer object. And
Takes
returns
a
it.
string and returns an int.
Okay, it takes the string and returns that integer. And if you parse into character, it'll give you some ASCII number or something.
It will raise an exception, but we don't know how to deal with exception. Yes.
Maybe mentioned that a long time ago.
What?
Oh, how are you getting that?
Yeah. How can you not resolve to string?
I don't think you use that by
Oh, I have no clue.
make a black line.
You know, if you highlight, you see the yellow bar on the edge right there.
Oh,
If you point to on that one, it doesn't.
oh, I'm gonna do that.
Let me do this.
See orange, yellow. Okay.
Yeah, I'm not very right. I know about it.
So if and we are converting them back into strings, so I can stick them back in here. What I can do is you give me a actually let's do this string get the last one, right? If it is a number, right? If it's an operator, then extract the two operators, operate on it, and then put it back. lied to you. You need 2 stacks. No, you don't need 2 stacks.
So push puts in the stack, pop looks at the top of the stack, peek looks at the bottom of the stack.
Peek looks at the top of the stack without taking it out.
Okay.
Why do you need to put them back at all?
Because you need to put the value that you calculated back into the stack. Actually, what you do is not pop.
What are we're trying to do? Oh yeah, we're trying to like, whatever order of operations we get from a string, trying to take a number, do that operation to that number.
Yeah,
we need
yeah.
to keep track of the value so far.
Yes.
Well, you could just create another thing to hold that value.
You could have 2 stacks, one of operands and one of operators. Or we could use recursion. But I was saved by the bell. I will come up with a cool and fancy way of doing it by next class. By the way, the next assignment is about collections. Not the one that's due on Sunday is about classes and inheritance. And it's actually mildly easy, right? The next one's about collections, and it's super easy because it's basically the same thing about arrays, except that now with collections. So don't think that it's actually very, very easy because I'm trying to show you that it's the same thing, or at least a big piece of it is because arrays are collections, sort of, kind of. So it should be super easy. Don't be surprised if it's super easy. Not this one, the next Sunday one. Many times people would just go try to complicate it because it can't be this easy, right? It is, don't worry. Anyway, I will see you guys on Monday.